1, 2, 3. I don't hear anything. Hej, hallå? 1, 2, 3. Hallå, hallå? Nu hörs det lite grann. Mm? Jag förstår. Ja. Jag tror vi kan köra utan, men visst är det de där gula man ska vrida på det? Den brusar lite. Ja, som bra. Ja, hallå, hallå? and now it's on. So it's mostly for the camera, but if we're rather close, so I guess. Okay. The beginnings of this talk, I was, surfing the web as you do instead of working. This was in March, and I found new things, things I didn't know existed, and I started thinking this could really affect how I design systems. I need to think a bit more about this, and one way to think more about it is try to make a talk. So I had this talk internally at Factor 10 like 2 weeks ago, and now have added a few slides and modified things, and this is my second run. See how it goes. So who am I? I've been a consultant for 20 years. 7 of those, last 7 I've been working at Factor 10. My title, I don't think we have titles officially, but usually when we talk to customers, then sometimes I present myself as a coding architect. And I also like programming languages. So I know a lot of them, but I don't work in very many. But these days it's mostly Scala and JavaScript, and I think. Okay. So this talk will be a lot about containers and stuff you can do with containers and stuff you can't do with containers. And in one way, containers are just like virtual machines, right? But they have some important differences that makes it easy for us to use these differences. We can leverage those in the system designs we do. I mean, key success factors compared to virtual machines. I mean, they are very similar, but they have a lot less overhead. They don't need to load the entire operating system. So they start much quicker. They use a lot less memory overhead. So, I mean, you can have a couple of VMs on a big laptop, but you can have hundreds of containers on a laptop. So I think someone has tried to squeeze in like 1,000 containers on a Raspberry Pi, and just to see if it works. And Docker, that's I have a couple of these icons telling when stuff was introduced, and this Docker 1.0 was June 2014, and I think we started using it in 2015, something like that. So if we do a little graph, it's a log scale, so there's 10 times faster. So a physical machine starts up in like something perhaps more than 100 seconds, but less than 1,000 seconds. A VM, well, more than 10, but less than 100. And a container, half a second. Depends on what you put in it, of course, but kind of. So this 2 orders of magnitude more, or less rather, enables us to do things. But we can travel further down here and see where we land and what happens. And one of the components we could do is talk a little bit about serverless, which also sometimes is called functions as a service. So it's kind of, you take your big service and you just extract one single function. So it's kind of a nano service, I don't know if you could call it that, but it's very, very small. Probably does only one thing. And some people, one example is image decoding, transcoding from JPEGs to PNGs or something like that. Video format transcoding. But serverless is I think I don't like the name serverless, because obviously there's servers involved somewhere. Perhaps not yours, but somewhere. So you don't care where. I think it's better, and it's a hilarious joke as well. So the first products that started offering this as a service, functions as a service, was the big Amazon and Azure and Google. And do you remember when it came out? I have a little calendar for that as well. It was in November actually, so it's almost at the same time as Docker containers. And to understand a little bit about what the potential for using serverless functions, we could take an example for a call center. I mean, typically, you have a call center with a number of employees. You don't want to have too many employees, because if you only have one caller, then the other ones are idle and cost money. But you have spare resources, reserved resources, just like in your servers that you have and services that you have deployed. You have perhaps spare capacity to handle, the anticipated number of users. So this isn't ideal. This costs a lot. You obviously want all of them active, and it's not very obvious, but this is the optimal solution, because as you obviously see, one of them don't have a phone call, so there's one free for taking the next call. So if this is the situation, you know that you have the optimum number of, because if you have the last one also in a call, then you don't know if someone was queued up. Okay, you could have your phone system could have that, but one spare is good. But imagine if that was, why do we design call centers like this with a lot of employees and spare capacity? And why do we design systems that have a lot of spare capacity? Because it's adding more people. The HR department, they can't just add more people in a second. Obviously, they take a lot of time to train and hire and so on. And even if you're using the cloud, AVS machines typically take a couple of minutes to spin up. So imagine if you had a design possibility for your design center. Imagine if you have some kind of cloning technology available. So you take your best call center employee, you clone him into an avatar software thingy, and then you just don't activate anyone. You don't pay. No one calling. You don't have any employees. Your call center is empty. No one calls. Then, as soon as someone calls, your cloning technology kicks in, and you have one to handle that. You don't reserve the capacity up front. If there's more callers, you add more of these clones. Or is it clowns? I don't know. Depends on which call center, I guess. But this scales up basically from 0 to as many as you want, because you don't have to manage this, the capacity part of it. You just provide the template for the worker. So, imagine that you had a call center, and then imagine someone invented cloning technology. You wouldn't want the old way of reserving. Have 200 employees in your call center. You would want to use it because you use the right amount of capacity all the time. So if we go back to serverless, this is typically container-based and also start on demand. But and also there's no cluster to provision. But you have this feature of the scaling feature that you can scale from 0 to infinity without the delays. But that's kind of a lie, because if it's container-based, you still have this perhaps 500 milliseconds of latency to kick one more of your containers into action. And for some applications, not all, but some applications, that's too much. I mean, if you have used AWS Lambda or Google Functions or one of these existing frameworks, they don't just take 500 milliseconds to start up a new instance. Maybe they could take 15 seconds, 30 seconds, depends on luck and scheduling of other things, I guess. So cold starts is a big problem in the serverless world, which is why people try to design systems to keep them the functions warm. You call them even though you don't have anything to convert. You convert the same image over and over just to have some of them running, so you don't have this for the real calls. You don't have the startup latency. So you have resources, read service resources. My argument here is that this affects system design, right? We all have heard, I guess, about the pets versus cattle. You don't want pets that you have to nurse. You want cattle that you can just replace. But you still have to care in the cattle world. You still have to. You have a Kubernetes cluster. You still have to care about the underlying machines, unless you order the as a service the entire thing. But then it's not cattle anymore, perhaps. So functions as a service often pay per service, per use, and as an example, Lambda, they charge per request, and if you have a runtime of more than 100 per 100 millisecond runtime. So if you stay under 100 millisecond runtime, you only get charged for one slot, and that will get something like a cost of $2 per million requests. So it's very, very cheap. If you have a million requests, if you serve them by having allocated a couple of machines, I mean $2, that's nothing compared to the fixed machine, reserved machine cost. So it's kind of cheap. I saw a presentation of someone having 400,000 users on a system, and they paid a Lambda bill of less than $50, I think it was. Okay, just a small, I won't go into a lot of detail, but if you were to design a system that were going to function as a serverless system, this is one way you could do it. This is taken directly from Apache OpenWhisk, which is an open source function as a service package, let's call it. So just very, very quickly, what happens is that requests come in, land in a controller. The controller talks to CouchDB just to see if you're authorized to do this and get some other information. Then you also check with the service registry, the console part, to see which of these Docker containers are already running. So you can address the correct one. You put it in a queue, and it eventually executes, which puts the response back into CouchDB, which then could send it back to your the original request, gets a response. So this part scales. The other parts is mostly the same, but this at least if you want lots of users, you have lots of containers. But this also, you need to have them warm, or they're going to be cold start costs. And can we do better than this? And there have been several attempts, and some of them, most of them, that I'm going to talk about are rather recent. So one attempt is an Amazon product, open source, called Firecracker. This is they sell it as what would a virtual machine manager. So it's not a virtual machine; it's a virtual machine manager. If it was designed from the start for containers and functions. So it takes a lot of shortcuts, and it uses Linux KVM, kernel virtualization functions. And it's really high performance. And this is from November last year. And if we look at where it places itself in this startup competition, It's like 10 times faster than a container to start up, but it doesn't run Linux containers. It runs a specialized virtual machine. So I'm not sure about how applicable it is for people who only have a lot of Docker images, but this is Firecracker is what they will. They are transitioning over to Firecracker for Lambda and Lambda Edge. So this is a product they're using themselves. Yes. So what they wanted was security and isolation from the virtual machines, but also the resource efficiency of containers. So it's kind of a interesting compromise. 50 milliseconds startup and only 5 megabytes of overhead per VM. So that's, you can run thousands of these on a machine, obviously. And it's written in Rust, by the way, and I like Rust, so that's why I mention it. And I'm not the only one who likes Rust. It's been, top most liked language in Stack Overflow service for a couple of years. Let's talk about how this intersects with something called edge computing. I think there's some confusion what we mean by edge, and one of them is because there's two different ones, I think. There's one actually on the user's device, your browser or your smartphone perhaps, or your computer, or the edge, the first hop after your device, but not in the data center, much closer to the user. So the CDNX, Content Delivery Network, that's CDN. That's close to user. Why do we want that? Because then if we talk about serverless, we could then talk about regionless, just as likely. A better name in that context. And why is this interesting? Why would you want to be close to your users? Because of light speed. Light speed is unfortunately not infinite. So just as an example, if you have servers in Amazon Frankfurt and you have clients in Malmö or in Stockholm, the Stockholm ones, by laws of physics, they will have 2 more milliseconds of latency. That's just unavoidable. And that's one-way trip, so it's 4 milliseconds of actual latency. So if you have the worst case, you have a user in Sydney and you have deployed to the Amazon East 1 in Virginia, that's 53 light milliseconds, and so over 100 milliseconds of just unavoidable delay if it's the best case routing a really straight cable, which is probably not the case. So this is why would we want to use edge computing? This is a map of Cloudflare, which is a content delivery provider. These are their locations. And if you compare that to Amazon's, the red ones are actual Amazon data centers, and the green one are planned data centers. So it's not a completely fair comparison, but you see obviously wherever you place yourself on the map, mostly you are going to have a purple dot closer to you. So you're going to be closer to one of these locations, the users. I mean, you could have a 50 user internal internet app, then you don't care about this, obviously, but if you have users around the world, it could be interesting to talk about this. So how do we benefit from this? And one way is a product that has been around a little bit, 1 year or so, called Cloudflare Workers. So Cloudflare have already a content delivery network for serving your static JS files and images and whatnot. But now they have workers, which is basically your service workers that can run in your browser, but they run in at their edge locations instead. And they're based on Chromium browser. The V8 engines isolate, and an isolated watch. I think it's fair to say that that's what's in each tab is a single isolate. So it's a copy of the runtime that's isolated from the others, but shares some logic, I guess. So it's JavaScript at the edge. And if you look at where this places itself on the startup competition, it only takes about 5 milliseconds to start up on a new isolate and load something in it. So it's 10 times faster as well. And what you have 5 milliseconds startup and only 3 megabytes of overhead, so it's a little bit smaller than the other one. So this is from a number from their marketing, so a grain of salt, I guess. But half of their responses is less than 13 milliseconds or faster. So that's, I mean, if you talk about the Sydney, Virginia case, that's, I mean, way faster than even halfway to. So if you could place one of the workers near your users, you could shave off, depending of where they are, obviously, and where you have deployed your service, but you can shave off hundreds of milliseconds in the best case and a couple of milliseconds otherwise. So it's they claim it's much faster than Lambda and Lambda at edge. And I'm going to just mention Lambda at edge briefly. This is basically a free feature of CloudFront, which is their content delivery network. And what it enables you is to run Node.js functions whenever there's a CloudFront event, such as an incoming request. And that's like 2 years old now. I'm not going to, I don't have any numbers for this, but it's, as they say, it's Cloudflare at least claim their workers are faster than this. So, can we do better than this, running JavaScript at edge? Well, if we start looking at something called WebAssembly, maybe we can. And WebAssembly was standardized and delivered to the major browsers in late 2017. And it's basically because JavaScript was never designed to be a compile target, yet we have many languages like that compile down to JavaScript. But if you think about this problem and design stuff for actually being a compile target, which is what WebAssembly is, I'm not expecting people to actually try to program anything in WebAssembly, but it's a compile target. So for C++, C and Rust at the moment is very well supported because those don't have any runtimes. But anything with a runtime, like Python or .NET or Java, you'd have to also port over your virtual machine to WebAssembly. But there's work doing that as well. So for those interested in compilers, a lot of languages use LLVM. And LLVM 8, which is released in March, it's no longer experimental, so it's easier for compilers and languages to target this now. So what did Cloudflare do? Now they started allowing people to use WASM instead of just JavaScript, and this was in March. Because Chromium is one of the supported browsers that run WebAssembly. So they developed a tool called Wrangler. It's a command line tool that just enables you to write Rust code in a specific way and then deploy that as compile it to WebAssembly and deploy it to a Cloudflare worker somewhere. And one thing that doesn't have, but which is coming as well now, is something called WASI, which is WebAssembly System Interface. Why is this important? Well, Lynn Clark, who is a principal engineer at Mozilla, she does great webcomics and information about, among other things, WebAssembly. And in March, they announced WASI, which is running WebAssembly stuff not only in a browser, but anywhere. Because what is the problem with running it in a browser? Because then you have a a lot of overhead if you want to use it for something that isn't browser related. So how important is this? Is this something we should care about? And let's see what the founder of Docker said about this announcement. Solomon Hike is one of the co-founders of Docker. He said something like, I wouldn't have created Docker if that was available when I needed it. So it's really important, he thinks. WebAssembly on the server, because what WebAssembly does is like leveling the playing field. As long as you can compile down to WebAssembly, then you can run in a lot more places, especially if the system interface is there, because what the compromise you had earlier was some kind of POSIX emulation layer, if you have heard of mscript and ASM.js and so on. They try to emulate and complete POSIX system, Unix-like system with file access and sockets and whatnot. That's just way overcomplicated when you don't need those things. So, another tweet from Solomon. Will it replace Docker? No, it won't. But he envisions something like WASM containers that will be available. So what is WASM container? That's not a thing. I'm just making that up, or based on the slides. But it could be a thing. It's what I mean is that sure you can have WASM plus the system interface that allows you to get data or send data and so on. But no one has done the thing that Docker did for. I mean, the tech behind Docker was available for a long time, but it was hard to use and not packaged well. But Docker really succeeded in packaging that into something with binary format for images and distribution of the images and starting and stopping containers and management and so on. So Docker containers aren't just the tech, because that was available for years before Docker came. So the WASM containers, the tech is there now. Someone will inevitably make something like Docker for WASM container, or even Docker will add support for it. So what if you know about WASM and VASI, what would you do if you had knowledge of that? Well, a company called Fastly, they developed a tool called Lucet, and Fastly is a competitor to Cloudflare. So it's another content delivery network provider. So they built a tool called Lucet, and that's their engine for their Terrarium engine, which is like Cloudflare Workers, but their version of that. And this was designed to handle every request Fastly handles, which is a lot. And they wanted to be able to run tens of thousands of requests per second in a single process using WASM containers. And to design this, it required a dramatically lower footprint than using something like Chromium V8 isolates. So where do we land on this? It was also in March, by the way. Where do we land on our little speed competition? Way lower, a couple of hundred of microseconds. So, and they have the even better marketing material, but I didn't want to over-exaggerate. But for loading a container in their runtime from disk, so it's not including a lot of overhead for a lot of management around it. But so it starts up really fast if you have it at hand, at least. So it's a VASI runtime. So it's not running in the browser. It runs WASM modules in another application. So it's only 5 kilobytes of overhead for each invocation of loading another module, WASM module. And this Lucet is actually kind of a compiler. It takes a WebAssembly module and just creates native code out of it. But it's still just like you can have your JavaScript or your JVM code actually translated beyond your intermediate code down to machine code, this is what they do as well. It's also written in Rust, by the way. So what if we merge all these things and talk about user edge on the device? Obviously, you don't have, you can't control what the user have, the capacity of their machines. And I mean, imagine running a Docker container on your phone. I don't think anyone would want that to happen. So, and also you don't want to run native code, which would be, I mean, for efficiency reasons, something called to compile down to assembly code and just run it. That's small and fast, great. But it's untrusted and unsafe. You don't really want that either. But if you have Wasm containers and you run it in one of these VASI sandboxes, then you can just control everything about it. It doesn't have direct access to the file system. You just hand it capabilities. You can read this file. You can't read any other file. This is the file you want, the user data file, whatever. So it's sandboxed, even though it's could be compiled to native code. So this is something that wasn't possible with Docker, but is now. So I see a lot of different uses for Wasm containers. Perhaps you have any ideas? I have a few, but if you have something that starts up, this is the premise of the talk, basically. If you have something that starts up in microseconds, at least say half a millisecond, say if you don't, and you just can run it on demand, and it doesn't take a lot of memory, and you could. So it's not a startup that you don't have to worry about keeping things warm anymore. Yes, you can use it anywhere. So one of the uses that I also found on Twitter was Kelly Summers. She thinks that, well, you could use it as a stored procedure thingy in a database. Then you can write your stored procedures in whatever language that supports compiling down to WebAssembly. And you would have good performance, and you don't have to write it in Transact SQL or whatever kind of language the database has. And she references the Fastly Lucet announcement there in the tweet. But if you look at your typical Kubernetes deployment, I mean, you have a couple of machines, depending on obviously the expected load. But if you have a couple of machines and you have a couple of, they are reserved for running. You have started your services. They're waiting for requests. You route them to the correct endpoint. But imagine if you don't have to have that. You just have one way of obviously could be that you have the reserved machine, but you don't have anything running until an actual request come in. Then you start up something that could handle that. And also we must also remember that startup time isn't the only thing that is a factor of course, because what if you're very close to the user thingy, needs to connect to Virginia to get a database record? Then you're back to your old solution. But perhaps you can have that as a stored locally somewhere, and you so it's just a hit the first time you actually get that request from the user. Then, as long as they don't move around, that data center has my record, the customer record for my purchases and whatnot. So what I was saying is basically that yes, startup is important, but there's other latencies. The state hydration part is also going to be important. That you have to design something there as well. This doesn't solve every problem, unfortunately. So just as a little bit of a quick run through of the landscape. There are more alternatives out there, but this is a couple of serverless thingies or with container tech. So the OpenWhisk one is based on Kubernetes and Docker, open source, the first ones. Lucet is also open source and runs WASM with a system interface. Firecracker is also open, and they are going to use it to run the Lambda functions. OpenFAS is also Docker based and just runs any container you have with a HTTP interface. Cloudflare Workers, just JavaScript or WASM. Lambda runs a couple of languages, and Cloud Functions runs also a couple of languages, and Azure Functions also a couple of languages. And they're mostly closed source. You can't really use them for yourself. But these parts, but some of these are not. These are more equal because they are the engines. You could design something around those. OpenFAS and OpenWhisk are more of the whole package, the scheduling of containers and so on. So Firecracker is the engine for Lambda, Lucet is the engine for Terrarium, Firecracker, V8 is the runtime environment for Cloudflare Workers, basically. But also I want to mention that we went down to 150 microseconds. I mean, if that's fine, but if we look at down at the scale down at 1 nanosecond, I mean that's basically what CPU add instruction takes. I mean 1 gigahertz is 1 nanosecond. Negative. You mean depend on AI perhaps can do that. You anticipate which button you were going to click, so it's already buys the bike for you before you wanted it. I don't know. Yeah. So I always wanted to say that I mean we are all a couple of magnitudes. I mean 1, 2, 3, 4. 5 magnitudes over, I mean, a very small basic machine code function. So we're still not there. But what do we get? We get isolation. We get the sandboxing with and this rather fast startup time. And if just someone adds the packaging up on top of this, I'm thinking this is going to be really interesting. And I'm also thinking that. This could and should affect your system design. I mean, reserved resources is like the call center you have with 200 employees, just in case. Perhaps you can do it in another way. Yeah, and to borrow a phrase from Stephen Fry, if you have been, thanks for listening. I also was sponsored by our company to a little giveaway book for a good question. So if you have any questions and I think they are good, perhaps you get a book. Negative. Well, I guess this is a negative book because you gave it to me. So I'm guessing that's a -1 book for you. Yes. Yeah. Yeah, because what do you need to run a stored procedure? If you're going to have a stored procedure that has access to some data, and what do we do in a stored procedure? We check out some products from it depends on what decade you were designing systems in, I guess. But if you have a logic that you want to run in somewhere else, plug-in system, either your application that has some scriptability, or I mean that's a case of database servers wanting to run a user-defined script on your data at the server. You don't want to download a trillion customer records and then do something with them and then upload, because perhaps you only wanted the response is very small, but you want to traverse a lot of data. So what could you do? If the database server was designed with a system interface, then you could program a WASM module that uses the system interface to read some data, customer record, and send out, write some data back. So you don't, your system interface is agnostic. It's like an operating system interface. You don't really care what kind of data is in the file. You just have a handle to some data and you can read it. So if you build something on top of that, you could obviously have in between your function and the database actual storage, you could have some translation thingies that provide you with more structured data. It depends on if that's going to be easier or faster or something. But what would be the upside? The upside is that you can write your module, your WASM module could be written in any language, which is a little asterisk, because at the moment, I think Rust, C, and C++ are the most usable languages. But people have been porting over .NET and Python and Lua, and there's a long list of more or less supported languages. And this is going to be a nice target for compiler writers and language writers. One interesting fact about I got sidetracked, but is that an answer to your question, more or less? Yeah. Depends on what, obviously, what you're going to do in your, or what the system is going to allow you to do. Perhaps you're not going to allow you to do something outside of a transaction. Perhaps you just write data summation functions, for example. It could be restricted to some kind of domain inside the database. That this is something you can write your own store procedure or module for adding. And it just adds some flexibility on the technology that gets that into the server. So I think it's a plugin system. We have a plugin, a DSL language for one of our products, but that's JavaScript now. And if we could have instead of having a JavaScript runtime, we have a web assembly runtime, then we could have a lot broader surface for what language are chosen for the DSL, for example. Yes?
I see for us that have been based for a while, I can notice some claims that Java was making, I don't know, 20 years ago, like sandboxing, these like, oh, let's run things in that sandbox, doing that, all these sounds like applets to me.
Mm-hmm.
And what would you say that Java did wrong at the time, that WebAssembly is doing right now, or what WebAssembly have learned that didn't take it that Java made at the time?
I think, was it Scott Neely who was the head of Sun when they launched, one of the bosses at Sun Microsystems? I remember him saying something like, why would you write anything in anything but Java? It runs everywhere. So what's the point of having other languages? And we all know that, yeah, well, some languages are suited for different tasks. There are example, Python. It happens to be that there is a lot of scientific computation libraries that people trust. So they turn to Python, not because Python is especially good at numerical computing. You could take a lot of other languages, but someone could have written NumPy and SciPy and whatnot in JavaScript and started with that, and then they have the scientific user base. So that's one reason, because WebAssembly is a compile target. It's not a language. You don't have to, everything has to be WebAssembly. You have to write it in WebAssembly. You can write it in a lot of languages. It's a little bit short list at this point that works really well, but it's going to be expanded to more languages.
Would you say that it's better target than Java bytecode? Because there are other languages also compile to Java bytecode.
Yes, because you could obviously have a, you could see it as a way of you could use Java bytecode as a compile target. That was a lot of, I mean, Kotlin and Scala and so on. They use that. But then you have then you will have a lot of baggage with it, because they were designed to run in a full computer operating system. And when they tried to restrict it into Java applets, we know what happened. That wasn't very useful. But this is restricted from the start. It was designed to run as a sandbox thingy. I think it's a little bit of a difference. This is more agnostic than the Java platform was, the bytecode platform, in my opinion. More questions? Yes, there's Mozilla has a runtime called WASM time. Lucet, I think, also can execute. So you can write a hello world container, which is a very simple WASM module, and you can run it locally with a command line command. Just get hello world, and you can run it in the browser and get hello world in the console, and you can deploy it to Terrarium, for example, and you have it executed as an edge function. So yes, there's things that can get you somewhere, but it's not as polished as Docker. You're not getting the book because he's my colleague, so that would be kind of cheating. Yeah. Okay. Depends obviously on what you're wanting to do with the request and what kind of request it is. I mean, if you're wanting to serve a web shop, then obviously it would be hard pressed to run that completely at edge. Then you have to download the product catalog somewhere and very close and so on. So I agree that this shifts a lot of the problem to now you have to get to the data quickly. How is that going to be solved? Can I cache it locally and just write it locally, and then transaction log shipping kind of way, write it locally at edge with my shopping cart, because you don't actually need the server to know about your shopping cart until you check out the thingy. You could, it could be running at least if you have the rest of the data, but and then you take the hit when at a later time, perhaps when the user is thinking about what color pants they want to buy. So yes, I think there's an interesting shift in what's going to be the bottleneck. I actually, yes, that's absolutely. And one thing I saw that I was going to mention, but I forgot, so good, thank you for reminding me, is some people are thinking about doing microservice architectures in serverless. And what does that mean? Because that's your request comes in at one serverless function and then calls another that calls another, just like your microservices does. But if you have the 500 millisecond thingy or 15-second worst case, I mean, you would have a minute. That would not be possible if you don't keep them warm at all times. But if you have a really quick startup time, and so it's not the loading that is a blocker, then it will probably shift to data fetching, data hydration. Yeah, I don't know of any particular solution to that problem, but I think that AWS Lambda they do some magic with your S3 buckets, for example. I think so they can have the data close to wherever you happen to be at the edge. But I'm not sure about that, how it actually works, what the downsides of that is. Exactly. Yeah, I think so. So if I mean if you have a like a really large Cassandra cluster, some kind, and you just ensure that whatever data you want is close to you. Mm. I mean, I think that's going to be, if this is going to take off, people are going to have these problems of storage hydration, and they're going to turn to how do we get it distributed to wherever the user is. I think that's going to be innovation in that part, but I'm not sure. Can't mention a specific product doing that at the moment. So I mean, location transparency, is that what you're? What kind of transparency? I think it's for some problems. For example, my shopping cart. No user in the world is interested in my shopping cart but me. So that kind of data that is relevant for me could live close to me, and perhaps it's not even relevant to centralize that. That usually turns out well. Uh, I think that is going to be a huge footnote explaining the caveats with that. I'm not sure I would want magic location thingies happening if I perhaps if I understood them well enough. But I guess I mean at a shopping web shop application, some data is interesting to have locally, and some data you must have centrally. So such as the current amount of stock of pink pants, you need to have that centralized. Yeah. Absolutely. Yeah, that's a great question. Um, I think that this enables a lot of new ways of thinking. That was what I was trying to illustrate with my call center example. I mean, you have your HR department, and they say that you can only hire one people, and that takes a week to train and so on. And if you don't have that constraint, perhaps you would run your call center the way you used to run it, because that's the way you're comfortable with. But you have a different design option if you have the cloning technology. Then it would be kind of silly to use the old way to do it. So this is just opens up new possibilities. Not sure how people are going to use it. I am sure that they are going to misuse it, just like you said. Microservices going crazy. Everything is a microservice, and too many and too small and too abstracted and so on. So this is also going to be easy to misuse. I mean, put everything at edge, and then you don't have any control over the central stock, for example. Yeah? Please do. I am open for more questions, even off the record, so to speak. Off the recording. Thank you, thank you. Yeah, have some pizza. I'm going to award this to you, because those are a couple of questions, and interesting ones.